Bon Crowder with math4.com. Math is not a four-letter word. Here talking about the Giant Pegboard from Discovery Toys and what you can do with it with triangles. So here's the Giant Pegboard. What you'll need is a Giant Pegboard or a pegboard and a ruler or some other measuring device and some rubber bands. So I have these two ginormous balls of Office Max rubber band balls, but they don't have to be balls. So the first thing I'm going to do is get rid of all the fun little toys on the front because I'm not going to use the front for this exercise. So here we go on the back. I'm going to talk about right triangles first, and then we're going to talk about how to look at other triangles. So first we can look at doing a right triangle this way. I'm having to do this kind of sideways because the orientation of the camera. This is the fun part, and of course there's always the danger of the rubber band snapping and putting an eye out. They say it's all fun and games until you put out an eye. It might be all education until you put out an eye. So you've got one triangle with the white rubber bands, and then I'm putting on purple rubber bands for another right triangle that's going to use a fancy math term, be congruent to the first. So there I have the first right triangle in white, which I don't know if you can see the color differentiation. The first right triangle is the bigger one, and that has 5 units on one side, 5 units on the other, and what appear to be 5 units on the hypotenuse, the diagonal side. Here's where you can use your ruler. If you notice, the hypotenuse side from center to center is about 11¼ inches, whereas the leg is about 8 inches as well as the other one because it's a square. So this is interesting to show this distance on the diagonal of a 45-45-90 triangle is not the same as this distance, which is not inherently known to children. So then you put on the congruent triangle and you have 4 across, and again there's 4 across here, except this distance is not the same. So you can actually use this to talk about, okay, so if we know that this distance is 8 inches, what might this distance be? And so they can do some division and figure out that each distance would be 8 divided by 5. Try again, 5 divided by 8. So we have 5 pieces divided over 8 inches. I'm still not confident in that one. Yeah, no, that's about 2 inches each. Oh, that is 2 inches each. How does that work? Aha! There's your learning, because they're going to do exactly the same thing I did. 5 divided by 8 or 8 divided by 5. In reality, just because there's 5 pegs doesn't mean there's 5 distances. You've got 1 distance, 2, 3, and 4. So you actually have 8 inches divided by 4 segments, which makes it 2 inches across. And so when you use the ruler, you go, oh, look at that. And then you can go across here and you go, okay, so this is 11¼ roughly. Well, how does that work? So that, again, that's 4 distances at 11¼ Maybe this would be easier. 3 distances at 8½. Maybe not. What if you did a smaller triangle? 2 distances at 5 and sort of almost 3/4? What's going on there? So this is a perfect opportunity to say, okay, exactly what is the relationship between this distance and this distance? So you've got a way to really get down and dirty with some right triangles with this Giant Pegboard. This is Bon Crowder at math4.com, reminding you that math is not a 4-letter word.